All right, guys, we are going to talk today about domain and range. So on our table of contents, in our guy right here, we're going to call this domain and range. We're going to do this on page 44 and 45. Okay, so if we turn to page 44, 45, I actually want to start on 45 and I want to write out a couple definitions for you. So we've been talking a lot about functions, and when we are dealing with functions, we always have two variables, sort of our x variables or our independent variables, our y variables or our dependent variables, and they kind of have fancier names, so that's what we're going to really talk about and investigate today. So first thing I want to define is domain. So domain is just a fancy way of saying all of the x values or all of our independent variable values or all of our input values. So domain are all of the x values. Range is just a fancy name for all of our y values or all of our dependent variables or all of our output values. So all of the y values. Now I say it very generally like this because I actually have a little acronym that is going to hopefully help us remember, and it's Dixie-Roy. So D stands for domain, I is input, or you can even remember independent, and X is X values. So those things are all talking about the same thing. Domain, input, X, all the same thing. Okay. Domain is just like the proper name for it, but we can always use input as that, or X value as that, or our independent variable as that. And then ROY stands for range, output, or Y values. Because again, they all mean the same thing. Range, output, Y values, all talking about the same thing. Those are our dependent variables. Excuse me. Now, when it comes to knowing all of them, sometimes that is really easy to just list. So I can list all domain and range values if my function or relation is discrete. So if function is discrete. And so what it means to be discrete is just like a collection of points. So just like not continuous, individual, I guess, is a really good word for discrete. So discrete is like individual points. Because if I only have like, I don't know, 10 individual points, I can just list all the 10 x values and all the 10 y values, and that's it. But if it's not discrete, if it's something that is continuous and goes on and on and on and on and on, like a graph may, we can't list all of them. We have to write it as an inequality. So write domain and range as an inequality. So those are our greater than or less thans if the function is continuous. And when I say continuous, I mean goes on forever. Which some graphs do that, some functions do that. So Alrighty, so if we take a look in our notes here now, this first little foldy guy, which wasn't totally cut, oops. Again, Dixie-Roy is just an acronym to help us remember that the domain of a relation is the set of all input values or X values. So it's the set of all input or X values. They all mean the same thing. And so when I'm trying to count domain and range, or when I'm trying to figure out domain and range, I want to make sure that I move from left to right. And that's because, again, our x-axis is left to right. ROI is just that acronym for range, is the set of all output or Y values. So set of all output or Y values. When I'm trying to determine my range values, I need to make sure that I move up and down. So move from down, well, I guess we could put bottom, that makes more sense. From bottom to top. So bottom of the graph to the top of the graph, okay? So we talked about the difference between set notation and interval notation kind of before when we were doing inequalities. So set notation is when I use my inequalities. Interval notation is that one we decided to skip, although 2 of you did it, which is so cool. So we might take a look at interval notation, but I'm just going to see how long we're at with the video before I decide to do it. So set notation just means I'm using my greater than and less than stuff. So like I was saying, if the graph is discrete, meaning it's just a collection of points, then we want to use the greater than or less than. Oh my goodness, I goofed this up. These are my own notes and I goofed it up. I got that backwards. If the graph is continuous, so it means it goes on and on forever, we want to use the greater than or less than if the point is an open circle or a dashed line, and we want to use the less than or equal to or greater than or equal to if the end point is a closed circle or solid line. So I know that's a lot to say, like I think when we do a couple examples, it'll make more sense. Now, if it's discrete, so if it's just a collection of points, so like a table or a scatter plot or a mapping diagram, we're just going to list each one because we can. So I actually want to start with that one first. So in this one here, because the discrete examples are easier, if I needed to list my domain, I'm just listing all the X values. So I can see them right here. I just put them in a list. So -4, -1, 0, 2, and 7. And then if I'm trying to list all my range values, I can just go see them. They're all over here. These are all the output values or the Y values. And I can just list them. It's -5, 0, 1, 2, and 4. Like that's super easy. However, both of these graphs are continuous because they're filled in lines that like cover thousands and thousands and thousands or infinite points over here because it goes on forever because of arrows. So I could never list all the domain and range values. So when the graph is continuous, I need to use my less thans or greater thans or less than or equal to or greater than or equal to symbols. So the way that I do this, if the graph does not have arrows, is I kind of think about, so for a domain, I think about moving from left to right. There is no graph until this spot right here. And then there's graph, and then there's graph. And then once I get all the way over to that point there, there's no more graph. So I can't go any further than that. So my domain for this one is that X sort of starts at -2 and ends at 5, which means that X is all the values in between. So in between is that and inequality that we talked about before. And in both cases, these are filled in dots and this is a solid line. So when its endpoints are closed circles or solid lines, we're going to use our equal to stuff. Okay. Now for range we go bottom to top. So the bottom of this graph is right here, which if I go over on the y-axis starts right here, and I have to go all the way to the top, which ends right there. And so the range of this graph starts at -3 and goes all the way up to 4. And so the y values are all the ones in between that. So it's another and inequality. And again, these are filled in dots and solid lines, so less than or equal to's. Now, if your graph has arrows, so like this one over here has arrows, I really think that the best way to determine your domain and range is to go to where the arrows are and decide which way are those arrows pointing. So this arrow over here is pointing up, but it's also slightly to the left, so up and left. This arrow over here is also pointing up, but it's also pointing slightly to the right. So when I think about my domain, again, I can't just list them all because this graph is continuous. It goes on and on forever because of those arrows. But if I think about domain, domain moves from left to right. And this graph is always going left, forever, because I got an arrow. And this graph is always going right, forever, because it's got an arrow. So I'm going left forever and right forever, which means eventually I'm going to cover all the x values. So my domain is all real numbers. Now, as far as range goes, range, we want to move from bottom to top. So this graph here is only ever going up. It's going up and up and up and up and up and up and up forever. So that must mean it kind of had a lowest point. And so the lowest that this graph ever got was right here at -6. And so the y values, because they're going up, 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 we're always getting bigger, 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 bigger. So greater than or equal to -6, because it started at -6 and it always went up, 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 up. It got bigger, bigger, bigger forever on the y values. So I'm not going to talk about the set notation stuff, but I do want to try these two domain and range examples without interval notation. But for the two of you that did try it, if you remember those brackety boys and the parenthesis boys, you could try it with the interval notation if you'd like. So this graph here is a lot like this one because it does not have arrows. And so if I think about the domain, going left to right, the graph begins here and goes until it gets to that spot right there. Now, the lowest x value that I had was -3. And then x is all the stuff in between until we get to 1. Now, on the -3, it's an open circle, so it's not going to be equal to. On the 1, it's a closed circle, though, so it will be equal to. Now, for range, we need to start at the bottom and work our way up. So the very bottom of this graph is down here at -4. And it goes up, 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 up until it gets right there. And it never goes higher than that. And so the lowest range value is -4. Range is y. It goes all the way up to 0. Now, at the bottom here, we have a filled-in line, like a solid line, and a filled-in dot, so that's equal to. At the top here, we have an open circle, but we also have a solid filled-in line. So it kind of fills that circle in, like eventually it is 0, so equal to again. And then last but not least on this one here, This one has arrows. So again, like I did with this graph up here, I go to where the arrows are. And I'm like, okay, which way are you pointing? Now this arrow down here is pointing down and to the left. This arrow up here is going up and to the right. So when I think about my domain moves left to right, and this graph is always moving left and always moving right. And so if I'm always going left, always going right, eventually I will get to all the x values. Range, I need to go bottom to top or like up and down. And this graph is always going down and it's always going up. So if I'm always going down, always going up, eventually I'll get to all the y values. Alrighty, so if we take a look at 44, we want to do a couple of these examples here. So if you kind of notice, we have these three and then this table and that and then like those. I'm going to do some of these and I'm going to have you guys try some. So out of these two graphs, I'm going to do this one over here. So if I were to name the domain values, I can just name them all because there's just a couple of points on here. And so this point right here is at the x value of -3. And then I have another point here, which is at the 1. And then I have one over here at 3. And then I have a point here at 4. And that's it. There are no more points. Now, as far as the range goes, range is the y values. And so going up and down, kind of all these points are at a height of 2. So I don't need to list 2 over and over and over again. They're just all at 2. So I would have you guys try this one. Now, when I take a look at this graph here, that is supposed to be an R. Let's go into that graph. If I take a look at this graph here, the domain, well, it's got arrows, so I need to think about which way it's pointing. This arrow is pointing only up. It's not going left or right at all. And this arrow here is going down, like only down. So I can't really tell where this x value is. Let's just say that this is -1, like the x value of -1. No matter where I go, it's only -1. So my domain value is -1 only. But for the range, it's going up and down forever. So eventually it's going to get all of them. So all y values. That's a weird one because like the domain had just one value, but the range has all values. It's kind of strange. So that's this example here. And I would have you guys try this one. So I want to skip this example because there are no numbers on it. I mean, that's kind of tough. So we'll just skip that one. But, well, we can skip this one too because, again, no numbers. And that's kind of annoying. Why did I not put numbers on these? What's wrong with me? This one's not so bad, though. So if I take a look at this table here, if I was going to do the domain, that would be all the x values. And I can just list them because that's all there is. So -1, 2, and 5. The range values, again, I can just list them because that's all there is. And so -4, 8, and 20. I would have you guys try this one. So like I would put this answer over here, this answer over here, and then that answer over there. So we're skipping those. We're going to skip these two just because, again, no numbers. But then I'm going to try this last one with you. So this one here, if I was going to talk about the domain, again, I just have points. So the domain on this one is -1. On that one is 1. This one is 3. And so is that one. So I don't need to list it again. The range, my y values, go up and down. So I'm going to start down here. And this is at -3. This one's at -1. This one's at 2. And then that one's at 4. Now, another thing to think about with all of these is you can ask yourself the question, is it a function or not? And this one is a function because it passes the vertical line test. And I would think about it for that one too. This one is not a function because it would not pass the vertical line test. This one is a function. It has unique x values, so none of the x values are repeated. And this one is not a function because it would not pass the vertical line test right here. So we want to remember that as well. So try out these 3 and leave me a comment about the domain and range values for those. Good luck, guys.